Back to topics and statics. This video is going to be on locating points in space. It's hard to describe what that means. Let's start with a picture. Here I've got 2 points, A and B. Hard to see these points. Let's see. Here's B, here's A. So what does it mean when I talk about these 2 points in space? Well, they're vectors. There's a vector that goes from the origin to A, and there's a vector that goes from the origin to B. Those 2 points, those 2 vectors, are what I would call position vectors. Position vectors always go from the origin of the coordinate system to whatever the point is that you're interested in. And so those 2 points have coordinates. A has coordinates 4, 2, minus 6. So the vector A is 4i hat plus 2j hat minus 6k hat. And similarly for B, the vector B, 6i hat minus j hat plus 4k hat. That's fairly simple. Those are position vectors. You go from the origin to whatever this point is. But what's more interesting is, or more important, is we often want a vector maybe that points from A to B, which are just 2 random points in space, A to B, but I need a vector that goes from one to the other. It's a very specific direction, in which case I talk about the vector that goes from A to B. And how do you find that? Well, I can look at this little triangle. Let's go to the next page. Here I want this vector that goes from A to B. I can look at this picture and see that RA plus the vector R that I'm looking for is equal to RB. That's just my picture of vector addition, that draw 2 vectors tip to tail, and that's how vector addition works. Well, the one I'm looking for in this picture is the vector R. And so I rearrange that top equation for the vector R. And so the vector R is going to be RB minus RA. If I want a vector that points from A to B, you take the final position vector minus the initial position vector, always. And then it's written out in component form in the last equation. This comes up over and over and over. You should get used to doing this. It's going to happen. So let's work a simple problem. Find the length of the cable that extends from A to B. So how do I go about doing this? First step would be to write down the 2 vectors, RA and RB. So the vector RA. So here's the vector RA. And what is the vector RA? The vector RA lies in the xy plane, so it's got 0 k component. But its x component is going to be magnitude, 4 meters, times the cosine of 20 degrees. And its j component is going to be 4 meters, sine of 20 degrees. And I can break out my calculator and calculate these numbers. This is 3.758 and 1.3681. And all of that is meters. And then I can do the same thing for B, the vector RB, right, which goes from the origin to the point B. The point B is in the YZ plane, so it has no x component, and it's just 4j plus 3k. Again, that's meters. So now the vector I'm interested in, the vector RAB, which goes from point A to point B, is RB minus RA. Plug all my numbers in. What I get is minus 3.7588 I hat plus 2.6319 j hat plus 3k hat. That's not right. That's right. All of that's meters. Then I find the magnitude of that by squaring each component, adding them all together, and taking the square root. I get 5.48 meters. So that's the length of the cable that I need to go from A to B. Very often where this shows up, where I go through this process, is not to find a vector that goes from A to B, but to find a unit vector that goes from A to B. And the reason it shows up is because I have a force vector, and I know where the force vector passes through. I know the line of action of the force vector. Right, I'd have 2 points that the force passes through. And so I want to write the vector as the magnitude times the direct times a unit vector. So here's an example. Here, I've got a cable that goes from A to B. It's got a turnbuckle in it that you use to adjust the tension in the cable. So the turnbuckle is tightened until the tension in the cable is 2.4 kilonewtons. Determine the vector expression for the tension T acting at point A on member AD. So I just want to turn that into a force. So I know that the magnitude of this force is 2.4 kilonewtons. I know that the vector is that magnitude times a unit vector that goes from A to B. So I need to find that unit vector AB. So I write down the vector RA. Right, that goes from the origin to the point A. So the vector RA is 0 I hat, right? It's plus 2j hat plus 5k hat. That's meters. The vector RB is 2I hat plus 3j hat plus 0k hat. So now I find the vector RAB, which is RB minus RA, which is 2I hat plus j hat minus 5k hat. Okay, so far so good. Oops. Let's give ourselves a little bit more room here. So now this vector, I need to know the magnitude of RAB. Whoops. I need to know the magnitude of RAB, which is 2 squared plus 1 squared plus -5 squared square root, and that's going to be in meters, which is square root of 30. So a unit vector that points from A to B would be 1 over the square root of 30. That's times 2I hat plus j hat minus 5k hat. That's the unit vector. So then this vector T is its magnitude, 2.4 kilonewtons, times that unit vector. So divided by the square root of 30 times 2I plus j minus minus 5k hat. So now we calculate all those numbers and we get 0.876 I hat. and that's in kilonewtons. This is going to come up over and over and over. So make sure you understand how to do this because you're going to use it. I got one more topic on vectors, and that's going to be the dot product. That'll be next time.